So here, right, there is, so week 2, lab 2, so there is a directory called scripts. So inside the scripts directory, you have something called counter_scan.txt. Okay. So here you can find the commands for every lab. So right now I'm using week 2 and lab 2. So I have the respective commands here. So I'll just go through all the steps which we did. So we are reading the synthesis netlist. We are declaring the up-down counter as stop design or current design. We are doing a link. We are linking this netlist and library modules. And then that scan configuration, you are giving the must type of scan. And then in compile scan, we are converting normal D flip-flops to scan flip-flop. And then we are writing out a file to check what is the actual difference between this counter.vs and how it got changed after doing compile scan. Okay. You can check whether this DFFs are converted to scan DFFs or not. And then we are declaring some signals which are required for scan operation, that is clock, reset, and then we have test mode. Test mode, we'll see how we use it. Apart from test mode, I am sure everyone knows what scan enable is, scan in is, and scan out is. And then we have declared that we have 12 flops, and we have declared that all 12 flops we want in one chain only. And then we wrote out a file. Also, we opened GUI and we saw if these signals are declared or not. Right? We stopped here. So, what is the next command? It is create a test protocol. So, first of all, let us see what this command actually does. So, before going to the next command, right, I'll just show you one thing in GUI. Okay. Let us open this counter design. So, we can see all the added ports. Apart from this, what we can see, let us try to analyze. So, okay. So let me consider this flip-flop. Okay. This out to reg 2. So this is the flip-flop. Morning in the theory class, I think you all learned that for every scan flop, your clock pin should come from top level port. Correct, right? This is what you learned, right?
Okay.
Okay. But here, can someone tell me, is it coming from top level port to this flop?
No,
No, right? It is coming from some other combo
output
logic, or you can tell it is coming
flip
from, yeah.
another
So it
scan
is,
flop, output of some other flip flop.
yeah, correct. This is like internally generated clock, you can tell. Okay. So it is coming from this clock. But what is the golden rule? Golden rule is that this clock has to come from top level port. Okay. So right now you might have, so it's quite a big design, right? So you, in future, maybe when you're working in projects, right, you will see more number of flops than right now you have only 12. Maybe in future you'll definitely see more number of flops. So that time you cannot open the design and keep seeing, okay, where is, you cannot go into each and every flop and check if clock is connected to top level or not. Correct, right? It's quite tedious to do that. So, and also, I'll show one more thing. This reset also, I think you saw, right, in the morning class. Reset also should be controlled from a top level port. But here it is coming from a flop. Okay. So, every time you cannot go back and check for each and every flop whether clock and reset are coming from top level or not. So, that is why what you do is you will tell the tool only to check this. Okay. So, you are telling the tool, please check and tell me whether all the flops are getting proper clocks and all the golden rules are meeting or not. Okay, what is the command to tell the tool? It is DFT DRC. Okay, what does DRC mean? DFT, I know you guys know what is DFT. DRC means
Design
design.
rule check.
Yeah, correct. Design rule check. So, are the golden rules correct? like in our design, whatever we have converted, right? Are the golden rules meeting or not? This is what the tool needs to check. Okay. So let us give this command and see what the tool will report. So here what the tool is telling, it has reported total 10 violations. It is telling 10 golden rules are violated. Like there are 10 flip-flops where you have golden rule to be violated. Okay. Total you have how many? 10 violations. See, the tool is telling there are 5 cells which do not have a proper design rule check. Okay. This is the number of cells which is having the violation. And this is the number of cells which do not have any violation. Okay. So tool is telling there are 7 cells that are valid scan cells. And there are 5 cells with design rule violation. So our expectation is this 12 flops, whatever we have, right? This has to come under one chain. But now, due to these violations, what will happen? Only 7 flops will come under this chain. 5 flops, what will happen? These 5 flops, it will not come under this chain. So, yeah, you need not give any command to open this GUI. Once you execute this, right, DFT underscore DRC, this terminal will open automatically. Okay, this visualizer, you can get it automatically. Visualizer or GUI. So here we have D1 violation. You have the number, how many? 5. And D3, you have the number 5. So just click on D1 violation. Okay. What all you got? You got each one of the names and you got what is the description. This is an uncontrolled clock input of flip-flop. Okay. So now I'll go to the first one. First violation, let us open and check what it is. You just double click on it, it will open. Okay. Okay. And the flop with violation rate, you can see it is in red. Okay. So till here, everyone understood, right?
I have a doubt.
Yeah.
DFT underscore DRC is standard, right? And it is fixed. We cannot edit or change or do anything. It's
Like
a command
command you
that will
want to
check.
edit?
No. It's a command that will check for design rule checks, right?
Yeah,
All
yeah, correct.
golden rules.
Huh.
And you said that we have other rules also. Out of these two, we have other rules also, and that it didn't show us here anything.
No, see, the thing is, I'll just tell you. So DFT, DRC, you are not mentioning whether it is a clock or show only clock, show reset. No, right? You are just asking any golden rule violation is there, you report.
Okay.
So it reported only 2.
Only 2 golden rules are there, or any other rules
No,
are
no,
also?
there are. Maybe in your next theory class, sir will continue with it, like golden rules. For now, I think he explained only 2, right? Clock and reset.
He explained only 2, that is okay. But when we are running this, right, the other type of rules,
No, if you have a violation in this design, it
then
will report. Correct, right?
yeah, okay.
If it doesn't have, it won't report.
Okay.
Similarly, like what happened here. Now 7 cells, it doesn't have any violation, so it didn't report.
Okay.
For this lab and here you have clock and reset violation, so it is reporting this.
Okay.
So this is D1 and then D3 also. D3, let us open. Same thing here, only you can see actually reset pin is also coming from a different clock, but let me open this as well. So D3 resetting, it is showing here. Okay, reset is coming from a different clock.
How this violation happened actually? We didn't give any connections, right, actually?
Okay, see, in your design, so functional design of counter. Okay, functional design of counter is this.
Okay.
Like it is getting clock from here. This is something functional. This is not related to DFT. Like why this violation came up. Okay, it depends upon the design.
Okay. So here, if we want to take it from the outside clock, I mean the top clock, then we can add a mux and redirect it.
Correct. I'll just explain that what we can do.
That has been explained already, actually, in the theory class.
Okay, I'll just tell you like how to use the test mode signal, how to connect it, which signal to use, all that you need to know in the lab.
Okay.
So here you have two flops, right? Whatever we saw, you have two flops. And what was happening from the output of this flop, you are getting the clock. So this is the issue now. So what is this pin? This is clock pin. Okay. So now we don't want this to happen. So as someone said, it is already explained in the theory class. So you will add a mux here. Okay. You'll add a mux and you yourself have declared one clock port, right? Which is a scan clock port. So you will connect this here. Guys, this is not a, like, not exactly represented as a mux, but please consider this as a mux. Okay. And then usually for mux, what else we'll have? We'll have an select line.
Yes.
Correct, right?
Mm-hmm.
Now, how we are connecting is we are connecting one input of this mux. So we are connecting one input of this mux from this flop. Okay. So this is the way we are connecting now. What are we doing? This clock, whatever connection is there, right? We are bypassing using the mux. Okay. So this is the top level clock port, which we have defined as a scan port. And then this is the test mode port. Someone asked, right, where we are using test mode. So this, what is the active state we have given? This is 1. Okay. So select line, if it is selecting 1. So test mode, if it is always 1, then it will always take this clock only, right? It will continuously select this clock. So even now, now what did you do? Instead of taking clock from another clock, you are taking clock from the top level port. Okay. So doing this will resolve the violation.
Okay.
Ma'am, what exactly is a test mode, ma'am? How can we define that?
Okay. So defining test mode, I think you have already seen, right? How to define a test mode signal. You are defining it as test mode and you are giving one active value. Okay. So why do we need this test mode? Let me tell you. So someone asked me, right? How did we get this violation? So like we didn't add anything, then but why we got it? This is because functional. So functionality of this is that Q of this should be connected to the clock of this. This is the functionality. Okay. So why we are using test mode is during test. Test means during scan, or you can tell during DFT. DFT is testing, right? So during DFT, you will make the signal as 1. Okay. During functional, they'll make the signal as 0. Because if you continuously keep this 1 only, then what will functional people do? Correct, right? They have designed something. Their functionality is different. Correct, no? So we cannot alter functionality. We are not altering the functionality here. So what is the pin that controls between DFT process and functional process? That is this test mode signal.
That is similar to some S pin in Mugstrom, ma'am.
SC pin.
Yeah, ma'am. Yes,
Yeah,
is
similar
select
in the
enable.
sense, similar in the sense when you are doing scan operations, right? When you are doing DFT and scan operations, this test mode will be 1 only.
Yeah, ma'am.
Only when you're doing functional, which we don't do in DFT, like there will be teams, right? One team is doing functional and one team is doing DFT. So people who are doing functional will take this pin as 0. Okay. Then this all this won't come into picture. Whatever is functionally how it has to work, similar way it will work. When you make this test mode as 1, that means you enter the DFT mode. Okay, you are entering the DFT mode and you are taking clock from top level port.
Okay.
Okay, did everyone understand, or is there any doubts here? Why we are doing this? What is a test mode pin? I hope same is explained in the theory class as well, right? I think sir has told you what is a test mode signal, why we are using it.
Not test mode. Sir explained with the help of Mux itself.
So now let us see what these commands will do, like how to define these commands. So right now you have reset issue also you have, and you have clock issue also, correct, right? So you need to tell the tool first which one it wants to resolve, like which one you want to resolve first. Okay. So you are telling that fix clock. Fix clock first you are enabling. You are telling the tool that whatever clock violations are there in my design, right? Fix it. Okay. So let us execute this command. So I'm telling the tool to fix the clock issues. And then what are all the signals I am defining? This is what I am defining for the input of the mux. Okay. What is the test data? Test data is the top level clock. Okay. So test data is something which you actually want. What do you want? You want clock from top level port, right? So you are adding this. Okay. And next what we are doing, we are adding the test mode port. So what is the state of this test mode port? You want it to be 1, correct, right? Only when it is 1, you will get the top level clock. Correct, right? I hope you're...
Already we gave it, right?
Where you gave already?
In the top, if you scroll up.
Oh no, see, that is you are just defining the clock. No, sorry, you are just defining the test mode. Okay, you are telling that there is a pin called test mode and you keep that active state to be 1. Now what you are telling is, you are telling the tool to add a logic. When you are adding a logic, you are telling what are the ports it should use.
Okay.
So here you are adding a mux, right? Whatever mux you are adding here. First of all, how will the tool know what is the signal it needs to connect? How does it know that select line should be test mode? And how does it know that the clock pin should be the top level clock port? It doesn't know, right? So that is why you are declaring all these ports.
This is only for the mux which we are going to add near this violations, ma'am.
No, not only mux. I think in theory class it is covered, right? You can add a mux or any other test that is why I'm mentioning it as test point.
Yeah,
Okay. You
combination.
can also use a combinational logic like OR gate. Okay. So do one thing. Like when you are practicing the labs, right? So skip these 2 steps. Don't give this because you are telling that it is already declared, right? Without this, just try it. Okay. Try to directly give the autofix command and see if it works. Okay. It might work. I'm not sure actually. I never tried. So you can definitely try it out. You can take it as like an experiment or a practice thing. Okay. You also try it. I'll also try it in the next class and let us discuss. Okay. So you are just giving an autofix command. Autofix means automatically tool only will fix the violation. But what you need to give? You need to give few signals. What is the control signal here? Control signal is test mode, right? Only when your select pin is 1. What is your select pin? That is test mode. So only when your select pin is 1, it will select this clock. Okay. So this is the clock type. Yeah, and this is type clock, and this is test data, which is the clock. One input of this thing will be clock, and control signal will be a test mode. Okay, so let us give this, and let us see what happens. So it has accepted. The command is accepted. Now let us run a DFT DRC and check if our issue is resolved or not. Is the issue resolved? Can someone unmute and tell me if the issue is resolved or not?
No, ma'am.
No, ma'am.
No, ma'am.
Alright, so there is one more step before doing all this. Okay. So what is that step? You need to use a preview DFT. Okay. What this preview DFT does is, now you have auto fixed, right? So let me give tool only will record. So tool will only start telling. See, it is doing an auto fix here. Okay, running auto fix. Is this fine? So architecturing test point. That means test point means it is adding some external logic. Okay. And what all it is telling, number of chains it is telling full scan and multiplexed flip flop, and this clock domain no mix we'll see in the further stages. Okay, so let us not go into it. And okay, so all these things it has told, correct, right? Now what has happened? Now we'll open DFT DRC and see. Right now what we did, we resolved only for clock, correct, right? We didn't do for uh,
Reset.
yeah, we didn't do for reset. Not sure why it didn't. Wait, still it is showing this. Do okay. So let me just give the commands again. Fix clock enable. Yeah, if you also want to do something like this, you can use an upper arrow key. Okay, it will show all the previously declared commands. So I gave this autofix command, and let me give this preview DFT. Maybe now I'm expecting it to fix at least the clock issue. Let's see. Still there, right? Okay. So actually after giving this, it should be fixed, but I think I'm missing something. Okay, I think I'll just look into this and let you know in the next class. So I think I'm missing something. I'll tell you why this didn't work. Okay, I'll just check on it again and I'll let you know. But till here you understood, right? Like what is the commands you need to give to do an autofix, and if you are giving a reset, then you have to follow these commands. Okay. So you have to fix each one of them separately, like fix the clock and then fix the reset. Is this fine?